This last video for 6.4 is super short. What it is comparing arc length and a central angle. So what it is that if you looked at, an angle in standard position intersecting a circle, we are going to be relating the radius of that circle to the sector angle, or the angle made by the terminal side and the initial side, and the length of the arc that travels from there. And so what it is they've actually done this in ratios. It's that like theta, the sector angle, is to the entire circle as a comparison of the radius to, or the sector angle to the circumference of the circle. So it's kind of like looking at a part to a part. So this little angle to the whole 360 degrees, or 2 pi, and then this arc length to the entire circumference of the circle. Now, the nice thing is that if you do this all in radians, you can use a really simple formula that relates sector length to radius to angle. And that is this. Theta equals S over R. So the angle equals the arc length divided by the radius. Or if you're finding arc length, you can do arc length equals angle times radius. Or if you're finding radius, you can do arc length divided by angle. But your angle has to be in radians. If you try to do this in degrees, you will get all the wrong answers, because this formula is set up with the circumference being 2 pi r, not 360 degrees r, and so it does not work in degrees. So I generally try to ask questions that are in radians, but if you do some in the textbook where they give you any of the angles in degrees, or they want the angle in degrees, just know that this formula only works for radians. The other thing is that you're given this on your formula sheet, but I remember this from this guy. So I don't know, it's personal pet peeve when I have to look things up. I just want all the knowledge in my head. So I remember this formula, and I've remembered this formula for 18 years because of the word SOAR. I'm like, this formula makes me SOAR, S-O-R, and then I can do any iteration from there. So let's look at what this first question is asking me. It says, find the measure of rotation in radians when a point 2 meters from the center of rotation travels 4 meters. What you have to figure out is what they're giving you. And so if we look at this in a picture, it says find the measure of rotation. So we're finding the angle. This is theta. When a point 2 meters from the center of a circle has of rotation, travels 4 meters. So the 2 meters is going to go here, and it's traveling twice that. So the 4 would go here. Now I only know how to draw this one to scale because I did it this morning and I did it horribly not to scale, right? So it doesn't really matter how you draw this. What matters is that the 2 meters is from, like, intersects the circle from the center, right? So from the center to the circle is the 2. That makes this the radius. The 4 is the length that it travels. That's going to make it its arc length, or S, and then theta is what it's solving for. So I'm going to say that theta equals S over R, and the arc length is 4, the radius is 2, which means my angle is 2 radians. And that's it, right? Beautiful, right? Nice exact number. Never happens with radians. Okay, the next one. Find the length of an arc of a circle, the length of an arc that has a radius of 5 with an angle of pi by 3. Pause the video. Give this a go. So for this one, we are solving for S. S equals theta times R. So theta is pi by 3. R is 5. So the answer would be 5 pi by 3. They didn't ask me for an approximate answer, so I will always give exact unless they tell me to round to a certain number of decimal places. So the length of your arc length would be 5 pi by 3, or whatever that would be approximately in decimals. Have fun!